Hey guys, welcome back to another video. This is stuff to keep you entertained. Today I'm going to be doing a project making some new hold downs for my CNC machine. The beginning of this video was supposed to be a complete tutorial on how to design them using VCarve Pro. Unfortunately, it's not working out that way, and I've had to chop this video up and speed it up in some spots because as I was doing it, there's some things that I didn't know how to do, and I don't believe I did them properly, so I'm not going to sit here and tell you this is how you do it. So basically, to start off, you open it up, you need to put the size of your stock in there, the length, the width, the thickness, and then you can start designing. So, narrating this, I'm going to make it real simple. Basically what I did was I decided how big I wanted the hold downs to be and basically made a rectangle. After that, on some of them I wanted them to have a beveled edge. So as you see in the video here, going very fast, I'm attempting to use different shapes and the weld function to make it easy to bevel the end of it. Unfortunately, I didn't figure it out in this video. I know there's going to be somebody that comments that knows how to do it. I did a lot of node editing. After I got done, I found out I had some messed up spots, and it just didn't work out the way I wanted. I ended up, making it work, but I'm not going to sit here and try and tell you how to do it yet because I don't even know how to do it properly. So anyway, the whole point to having the beveled edges on some is to have a smaller contact point in case you have a tighter spot that you need something held down. And I think I'm going to have to redesign them because I'm not really happy with the ones that were beveled. So anyway, in the video you see here, I've got all my my pieces laid out, and now I'm putting the slot in the middle for the bolts to go through into the wasteboard, and that's adjustable. That's why that slot is so long. So the slot's 1/4 inch wide because the bolts I use are 1/4 inch wide. And I'm going to try and keep up with this video the best I can. If this is boring the heck out of you, you can skip to 6 minutes and 40 seconds and then get into the good stuff. This is unfortunately turned out really boring. So anyway, after I decided how long I wanted the slots, where I wanted the slots in relation to the actual hold down, then I'm going to go in here and just do a bunch of copy paste, and put them all in the same position on every piece. I think I'll speed the video up here in a minute. Anyway, this is unfortunately, like I said, I apologize. This just turned out like crap, but hey, when you got a full-time job and you got stuff to do, you don't have time to do things over sometimes, so that's kind of what happened here. But anyway, the slots that you see there, they're going to be cut out with a 1/4 inch end mill. The ends of them are square in this video, but I want them round. And using 1/4 inch end mill, they will be round because it can't cut a square corner because it is round, and it's only a 1/4 inch wide. So naturally, it's going to cut a radius curve in there anyway. See here, I thought I sped this up a little bit, but I guess not. Hopefully, it'll start going fast here in a minute. So anyway, what am I doing? That's right. Instead of putting a slot in every single one, I just copied and pasted the first one after I got it the way I wanted it. Once again, I'm sure there's an easier way to do this, or a better way to do this. In your toolbar on the left-hand side, there's the a nesting function. There's all sorts of functions, and somebody a lot smarter than me can show you how to do it correctly. But yeah, this is the way I did it, and I think this video, even though it's not very informative yet, might help somebody because. Sometimes you just have to do things by yourself and figure it out. Not a lot of people actually like to watch these how-to videos when it comes to using software. I happen to be one of them because they put me to sleep. If I really, really need to know how to do something, then maybe I'll watch one. So this step right here, what you see is I'm trying to create a 6-sided polygon. Oh man, what the heck is a 6-sided polygon called? Okay, you know what? Yeah, it's a 6-sided polygon. Hexagon? Yeah, hexagon. Anyway, what those are going to be for is the recess. They're going to be a recess pocket for some nuts that are going in there. And if you watch the rest of the video, you'll see exactly what those are for. And if you watch the rest of the video, you'll see that I absolutely screwed it up a couple times. But in the end, I got it working and I got it the way it needed to go. So I put slots in all of them. I put the hexagons in all of them. Here's the also put 1/4-inch holes inside the center of the hexagons. That's going to be for the bolt to go through, and you'll see why that is here in a minute too. Here I am grouping them all together so that they'll cut at the same time. Selecting your tools, you know, how many passes, your feeds and speeds, all that good stuff. Man, I wish I'd have taken my time a little bit more on this to show you why I did all this stuff, but anyway, you know, it is what it is. So here we are designing all this stuff, and what you just saw there was the program telling me, hey, your vectors are open, and sure enough, here I am trying to fix it because, once again, I didn't know what I was doing, and you know, that was the end result. But we got it, you know, we got it worked out. So just creating tool paths for, you know, my cutting out all the pieces. And there we are in the end, checking everything, and that's it. Saving files, putting them in the desktop, getting them ready to take out to the garage. So anyway, yeah, if you have any questions, ask somebody that knows what they're doing, and I'm sure they'll answer them. No, really, I'll answer some questions if you have any. Hey guys, welcome back to the shop. Sorry about that little tutorial video. What I was attempting to do was a narrated voiceover VCarve video on how I actually design these. Unfortunately, I didn't really know how to, so I was winging it. Normally, I would actually go in and design it beforehand and learn the different techniques and then make the video. Unfortunately, I'm a little pressed for time today. I got a lot going on, so I didn't really have time. So I sped up that video, and you know, I put a little voice behind it, kind of to let you know what I was doing. But for the most part, it didn't turn out the way I wanted to. So apologize for that. There's automated things in VCarve that does everything for you and does it in multiples for something like that. I don't know how to do all of them. I'm sure somebody will chime in here and explain what I did wrong or what I could do that was easier, and we'll all learn from that. And that's kind of the point of some of these videos. But basically, I want to make some hold downs that are better than the ones I've got. I had two different designs on there. A bunch of them are just straight edge, and some of them had some angles in them with some sharper points, or they come to a smaller point on the tip. And there's a reason for that, and I'll explain it after I actually make them and show you how I plan on using them. So once again, I apologize for that that video with the software tutorial. It didn't really turn out the way I planned. So either way, let's go down to the bench. I'm going to show you exactly what you need to make these, assuming that they're going to actually turn out the way I want them to, and then we'll get into the video and show you how I'm actually going to cut them out. So let's check out the tools needed to do the job today. Okay, so what we have here is an assortment of things. The first thing, the most important thing here, is the wood we're going to be making them out of. I decided to go ahead and use this 1/2-inch thick poplar. There's a very scientific reason behind why I chose this board, and that is because it's the only 1/2-inch solid wood that I had laying around the shop. So there's your science for the day. Anyway, 1/2-inch thick is the thickness I'm going to make these. If you notice on the video with the software, I designed them all running this length of the board. The reason for that is I want the grain going with the long edge of the hold down, because your grain is going to be stronger going this way than it is cross. So if I made them, you know, like this, you potentially snap them in half when you go to tighten them down, which, you know, I'm not really sure how this poplar is going to do anyway. It may snap in half and I'll have to redo it, but I've already got the file saved, so all I need to do is, you know, find me another 1/2-inch piece of, you know, oak or something. So as far as tools go for the router, you're going to need a 1/4-inch collet, and you're also going to need the 1/8-inch collet. Now somebody commented on one of my other videos and asked me what collets I use for my router. I purchased these from PreciseBits.com, They come in 3 grades, and each grade is a higher precision than the other. And of course the price goes up, and if you get their what they call extreme precision, I believe they say there may be a wait time, because I'm assuming they have to calibrate them to meet their standards. These are their lowest grade, which are still probably far better than the ones I was using. But Precise Bits, I'm not sure. I'm pretty sure that's not their brand. It says TNT on the actual collet itself, but they sell them in their box. So I'm not really sure, but they work pretty good. And the kit that you buy also comes with this wrench, which is a lot better than the one that DeWalt provides, I believe. So you'll need both of those collets. For bits, we're going to do this with just 3 of them. You need a 1/4 inch end mill, flat end mill. You need a 1/8 inch flat end mill. This is going to be used to cut out each one, the final step. You could also use the 1/4 inch. I don't know which one would actually be better to do it with. I chose the 1/8 inch, and that's just what I'm going to use. And then you're also going to need a 1/16 straight end mill. And this is only going to be used to cut out the pocket for the nuts. And the reason you have to use a smaller bit is so you can get a more defined corner. If you use an 1/8 inch, you're going to have a heck of a round over on each corner. And you want these to fit in that little pocket pretty snug. So we're going to use a 1/16 inch for that. You're also going to need an assortment of the bolt of your choice. I chose 1/4 to 20 with a hex head on them. The reason I use these is because these are the same ones that fit in the T-nuts that I made the wasteboard out of. And I'm just going to keep going with these because I like them and I already have a bunch. I got some really short ones, I've got some real long ones, and we'll go over why, because these little bitty short ones right here don't really serve much of a purpose. They wouldn't even hardly reach the hole in the bottom, but you'll see why I chose these. You're going to need measuring devices, obviously. You know, my cheap little Harbor Freight calipers, you know, they may not be the most precise in the world, but you know, they get the job done. Tape measure for measuring your boards and whatnot. And you're going to need some sort of adhesive. The adhesive is only going to be used to adhere the nut into the pocket. And once again, you'll see after I make it why I'm putting that nut in there. You can use super glue or epoxy. I don't know which one I'm going to use yet. I needed both because I'm out, so I bought both, but I'll decide when it comes time, depending on how the nut fits in the pocket, because it's not going to be a the nut's not going to be used in any sort of stress, so it doesn't have to be a super strong glue. So anyway, that's what you need to do this project, and let's get started. Alright guys, I stopped that in the middle of it because I noticed I was having a problem. I believe it's what they call tool deflection. Let me see if I can get it to focus in on this real quick, and I'll show you. So these pockets are supposed to be straight walled, basically. And what I was getting, which I don't know if this is going to show up, I'm getting, as you can see, some sort of an offset there, and I think that's because I had my feed rate way too high and the tool's actually bending. So I'm going to go back in and I'm going to change the feed rate to a lot slower for that tool, and we'll see if we can't fix that little issue, and we'll give it a shot. Okay, I went in and changed it. Originally I had it set to 60 inches per minute, which was way too fast. I changed it to 20 inches per minute, and we'll see if that solves the problem. I'm not going to bother filming this because it went from a 9-minute operation to 23 minutes. So we'll just show the final result and see if it fixed our little issue. Okay, we're back. And no, we're not done, because it's still doing the same thing. I think I figured out why though. Okay, bear with me. So when I do my engraving, my drag bit is very long and I have to raise the router. So normally I have this all the way down and flush. So there's no way it be offset. For the purposes of using a drag bit, if this is canted just a hair, I don't think it would really affect much. Maybe it will. But either way, I'm going to lower this down and I'm going to try one more time and see if that fixes the problem. Okay, it looks like that was the solution to our problem. Everything's running good now. The only issue now is that for some reason when I went to rehome the machine, it did not want to keep its old zero. So I'd already started cutting and I had to re-zero the machine. It's kind of hard to get it perfectly to the same exact spot as you had it last time. So in this case, that's what happened. So for the holes that it's already machined, there's going to be a hair difference. But for this operation, it doesn't have to be like extremely precise. But all the ones after that will be just fine. So check it out. You can hear it taking off that little tiny bit that it left behind on the last one. So I think this is going to work out pretty good. Okay, I'm sure you're getting tired of me popping in here saying, hey, we did this wrong, so let's change this. But I did have one more thing to change. What I did was I realized that I made the pockets a little too small for the nuts, and they wouldn't fit in there properly. It wasn't due to a measuring error, it was due to a typing in the measurement in the wrong place error. I'm not even going to get into it anyway, I fixed it. So when you do your measurements for your pockets on a polygon, you've got the option it gives you is basically to measure from the center of the polygon out to the edge or the tip. So I used my calipers first time, measured, and then I cut that in half and said make it this size. Well, it shows you on a 5-sided, and I should have done it on a 6-sided, which would have been the flat ends and not the tips, blah blah blah. Okay, anyway, so what I did was I got back in the program and I just selected each polygon and sized it with the sizing tool and not the polygon tool. If you're totally lost, it's not that big a deal. One of these days maybe I'll get into it, but either way, so this last pocket that I'm doing is working, and let me show you. I paused the operation right now. The machine is turned off so you don't have to listen to it, but let's take a look. Is that not a perfect fit? Or what? That's what I'm looking for. Nice, flat, perfect fit. And the only way to take this thing out is going to be to, come on, focus. Anyway, so this nut goes into this pocket, and you'll see why. I'm sure some of you guys already know what this is going to be for, but there you have it. Fits perfect. It'll just require a tiny bit of some sort of adhesive to make it stay, because it will not, it's not so tight that it'll stay by itself forever. It'll have a tendency to pop out, but as you can see, I finally got it right. So let me finish this and we'll go on to the next step, because this is getting old. Okay, last step is done. Take this thing off and see how much work we're gonna have to do to finish cutting them out. I think it's just a paper thin piece of wood left holding these things in, but I should have gone just a hair deeper. I try to make it to where I don't actually cut into the wasteboard as much, but sometimes that leaves you, well, I can see through it. I don't think you can see it in the video, but they should just pop right out. Okay, let's clean these things up real quick. Okay, so we're finished cutting everything out. We got them cleaned up. They look okay. I'm not really too sure about this poplar. I think I'm gonna have to redo these in an oak or something. Be a lot nicer, but for now, these are gonna do it. All right, so here's the theory behind the design that yes, I've stolen from other people. It's not my design. Basically, you have a 1/4 inch hole. You have 1/4 inch slot for your bolts to fit in. Not much play. Good to go. These nuts will go inside this recess and they'll be super glued in. I'm not gonna super glue it right this second, but you'll see what this is for. All right, so here's your piece of stock. You need to secure this to your board. If you just had a flat hold down, it'd be at an angle and there's nothing biting. So what you do is you take one of your screws, you thread it in there, and you can set it to your stock, whatever you're doing there, to where it sits fairly flush. That one's a little long for that piece. I don't know why, for some reason my camera overheated when I was doing that router clip there, but hopefully it'll make it through this. So you got something kind of like that, and then you take another one that fits. That's why you need assortment. Yeah, so that's going to be too short. Then you can secure your next one down like so. What that does is a couple things. Number one, it gives you the perfect amount of leverage. Instead of just on the edge, it gives you a lot more bite. And of course you can back that off as little as or more as you need. But if you see, the reason I cut that groove in there was to accommodate the safe Z. Hopefully I can figure out how to change that too, because mine is way too low. So you know, after you're finished with your tool path, your machine, you know, it lifts up to a certain level and it travels back to the 0 point on your piece. Well, if you have a smaller lip on your hold down, it'll keep it from hitting that. You can also change your Z, which I need to figure out how to do. So that's going to be my next Google search, is how to change the Z. So what do you do if you have a big piece of wood you want to hold down? Well, the theory is the same. Obviously, if you're making a big old thick piece like this, big old chunk of walnut right here that's what, 1.5 inches thick or so, you're going to need a longer bolt. So you're going to take your change your bolt there, and you just have to decide which one's going to be long enough to accommodate the hold down. And it's just a little trial and error, but you look right here and that one's plenty long, and you take a real long bolt and you know what, that bolt's not even long enough. Looks like I need to find some longer bolts, but in theory, if you had a long enough bolt, that would go down in there, and well, maybe that'll work without that. Nope, doesn't bite. Okay, so apparently I need to find some longer bolts. I don't do stock this thick very often, so I'll probably buy just a couple and keep it on hand. But you get the point. You tighten this down, it's going to hold pressure on this, and you've got a hold down that is giving more clamping pressure on more surface versus doing it like this, where you know it has the potential to move. You do it like this, where it's flat, it's not going to go anywhere. When you get all four of them, there's no possibility for it to move, really. So anyway, that is my design. Like I said, these just have to be somehow adhered to the inside. I'm going to use super glue. I think that'll work. They already fit pretty tight. And then you've got an adjustable hold down. Also, the reason I went all the way through here is to accommodate, you know, maybe you only have one bolt left or something, who knows. For whatever reason, you may want to, heck, you may even want to use that hole to thread to something to, you know, have this thing, you know, act as a straight edge on a table with a pivot. You never know. Anyway, not my design. I've seen these done this way in many places before, but it seems to be a winning design anyway, especially for what I need to use it for. So anyhow, you know, this project, we failed a few times, but we came back and we fixed our problems, and that's kind of the whole point of this. Do not get discouraged when you make mistakes. Find a way to fix them. Use a little ingenuity and finish a project. When it's done, it'll be worth it, and you'll be glad you did. Don't get frustrated. Just keep trying, keep doing, and eventually you'll get it figured out. Anyway, thank you for watching the video. If you have any questions, comment, please subscribe, and let me know what you think. And once again, I appreciate it.